In this recording, we will look at the topic of kinematics. Now, kinematics is an application of differentiation. It's about a particle moving along a straight line. So let's take displacement first. Displacement is represented by the letter S. Displacement is distance, but as a vector quantity, and it can be negative. So if you're moving in the opposite direction. The displacement is how far a particle is from a fixed point. Next, we have velocity. So if we considered distance, the rate at which distance changes in terms of time is speed. Now, this is similar to velocity. So velocity is speed in a certain direction. It is the rate of change of displacement, and it is a vector quantity. So, because it's the rate of change of displacement, if you differentiate displacement, you get velocity. So we can show that by ds by dt, change in s, the change in displacement over the change in time. And finally, we have acceleration. Which is also a vector quantity. It can be positive or negative. Negative is deceleration. Similarly, if you differentiate displacement, you get velocity. If we differentiate velocity, we get acceleration. Because acceleration is the rate at which velocity changes. So displacement differentiates to give velocity, and velocity differentiates to give acceleration. That is what you need to remember really with this kinematics topic. Okay, let's just have a look at a couple of questions here. You can decide when you're ready to have a go with them yourself, and you've got about 5 questions. So when you do feel ready, put me on pause and unpause when finished with the question to see if you've got it correct. Okay, so the first question, we've got a particle is moving along a straight line. The fixed point 0 lies on this line. The displacement of this particle from 0 at time t seconds, where t is bigger than 0, is s meters, where s equals t cubed minus 9t squared plus 12t. So that's our displacement. A, find an expression for velocity. So we know that displacement differentiates to give velocity. So let's differentiate the displacement. So 3t squared minus 18t plus 12. That is our expression for velocity. Part B. Find the time at which the acceleration of the particle is instantaneously 0 and the displacement of the particle at this time. So we need a formula for acceleration first. So let's differentiate velocity. Let's put it equal to 0 because we need to know when it is 0. So it's at t equals 3 seconds. But we don't want to know the t, we want to know the displacement. We need to put it in our displacement formula. So the displacement is negative 18. It's 18 meters from the start. Okay, question 2. A particle is moving along a straight line and passes a fixed point 0. The displacement of the particle from point 0 at time t seconds is s is equal to a third t cubed minus 5 over 2 t squared plus 20t minus 15, where s is measured in meters. Initially, how far is the particle from 0? So it's initially, time is 0. If I sub that into the formula, I would get minus 15. How far is the particle from 0? It's just 15. I'm just looking, yeah, meters. Minus 15 means it's in the opposite direction, but they're not interested in that. How far away is it? 15 meters. Find in terms of t the velocity of the particle. So to find the velocity, we need to differentiate displacement. So times by the power, 3 times a third is 1, take 1 off the power. Times by the power, take 1 off the power. So in terms of t, our velocity is t squared minus 5t plus 20. Find the time at which the particle's velocity is at its minimum. So minimum and maximum points occur when at stationary points. Stationary points occur when the gradient's 0. So I'm going to find dv by dt and put it equal to 0. Let's make t the subject. So the time at which the particle velocity is at its minimum, it's when t is equal to 2.5. Part D, how long is the particle decelerating? So the particle decelerates when the value of the acceleration is negative. So we need to find dv by dt first. We need to differentiate velocity to find acceleration. We need to when that's less than 0. So let's solve this inequality. So when t is less than 2.5. So this is really, if t is less than 2.5, t cannot be negative, so 2.5 seconds. Question 3. A particle is moving along a straight line that passes through the fixed point 0. The displacement s meters of the particle from 0 at time t seconds is given by s is equal to 2t cubed minus 5t squared plus 6t minus 9. 5. Find the value of t when the acceleration of the particle is 5 meters squared. So we need to differentiate the displacement to get velocity. That's our v. We've differentiated v velocity to give us an expression for acceleration. To find the value of t when the acceleration of the particle is 5 meters squared, so let's put it equal to 5 and then make t the subject. So t is 1.25 seconds. Question 4. Particle P moves along a straight line that passes through the fixed point 0. The displacement x meters of P from 0 at time t seconds where t is bigger than or equal to 0 is given by x is equal to 4t cubed minus 27t plus 8. The direction of motion of P reverses when P is at the point A on the line. The acceleration of P at the instant when P is at A is A meters per second squared. Find the value of A. So here, let's just look at this idea. The direction of motion of P reverses when P is at point A. So when velocity is negative, it means the direction of motion is opposite to the chosen positive direction. So we need to find out when the velocity is negative. So we have displacement here. Let's differentiate to get velocity. I want to find when it's equal to 0 because that is when the direction of the motion reverses. So t is 1.5. But we want the acceleration at that time. So let's differentiate our velocity, which will give us a formula for acceleration. Oops. And now we can sub in our 1.5, which will give us the acceleration, which is 36. Question 5. A particle P is moving along a straight line. The fixed point 0 lies on the line. At time t seconds, the displacement of P from 0 is s meters, where s is equal to t cubed minus 9t squared plus 33t minus 6. Find the minimum speed of P. Okay, so speed, or velocity is speed in a specific direction. So let's differentiate our displacement. 3t squared minus 18t plus 33. So when is well, we need to find the minimum speed of P. So maximums occur when the stationary point is 0, when the gradient is 0. So we need to differentiate our equation for velocity and put it equal to 0. Add 18 to both sides, divide both sides by 6, which gives you t is 3. So we know the minimum speed occurs when t is equal to 3. Let's substitute this t equals 3 into our speed formula, which is here. Gives us our velocity, or speed is 6.